So this is John, and today I am teaching him node analysis. Yesterday we learned about nodes and different vocabulary. So today we're going to apply that vocabulary. And what we're going to find is the voltage of these three nodes. I named it V1, V2, and V3. So the equation that we're going to use to do that, we're going to find a system of equations. We're going to find multiple equations with these variables in it. Right? We need three equations because we have three unknowns. But we're going to find three different equations using this node analysis. And the law is the conductance of self times the node that we're specifically talking about, minus the summation of the mutual conductances times the voltages of the neighboring nodes, and that's equivalent to the current coming into that node minus the current going out of that node. So that's going to be our equation that we're going to go off of. And so let's break it down. Well, the node that I'm talking about right here, it's the node that we choose for that particular equation. So for the first one, we're going to choose this node, V1. And before I get into that, it's good to know that these are resistors, right? Remember that from yesterday. And this is a resistance. This is an ohm, and it's in resistance. Conductance is the opposite of resistance. It's the inverse. So, since it's 1/6 ohms of resistance, the conductance is just 6 Siemens. So, those are the terms that we're going to use in our equation. So, does that make sense?
Yeah.
So, first one, we're going to do V1. The conductance of itself are those two resistors. So 7 plus 3. Oh my gosh. I'm going to confuse you. Whoops-a-daisies. 7 plus 6, because of those two right there. They're connected to this node, V1, because that's the node we're talking about, minus the summation of its mutual nodes, and there's only one. Can you guess which one it is?
V1.
What's the mutual resistor? It's sharing, V1 is sharing a resistor with another node. Which one is it? Is it this node? Or is it this resistor or this resistor?
That 1/7 resistor.
Yes, that one. So that's the one that's going to go here. V2, that's the other node. And that's going to equal the current flowing in minus the current flowing out. These are current sources. And these arrows are telling you where the current's going, and the numbers is the amount of current that's going. That's the amount of current. And so, if you looked at this right here, right, is this current going in or going out? Out, right. So there's nothing coming in, and there's 25 coming out. So that's our first equation. We did the same thing 2 more times. So V2 is a little bit harder. You're going to have 7 plus 3 V2. That's itself. But there's two others. There's V1 and there's V3. Right? It's neighboring two different nodes. And so we'll start with V1. The mutual resistor of V2 is V1. Is that 1/7 ohms, which is 6 or 7 Siemens. times V1. And since there's just two neighbors, you just do it twice. There's two terms. The other mutual conductor is 3, V3. Now the current flowing in is 6D and 10. There's nothing coming out. That's our second equation. Third equation is going to specify V3. So its self-conductance is 4 plus 3 V3, and the other is V2, and its mutual conductance is 3, V2. The current flowing in, V3, is none. The current flowing out is 10. So, give me a second, I'm going to write these equations again. Okay, so these three equations, I just rewrote them. I rewrote these three equations into those three equations so you can see it better. But since we have three unknowns, like I said earlier, we have to have three equations. We can use system of equations. There's actually an app on my TI-84 Plus that I'm going to put in the description. I'm going to make another video and put it in the description to explain how to do that. But and I'm going to do it right now on my app. For V3. And those are your three answers based on node analysis.